Welcome to a new episode of PLO Order Videos. File name for today is Basic Poker Math. How much do we need mathematics in poker? Are math overrated? Do we need to be mathematical genius to make money in poker? What's enough? And, well, let's get started. First of all, poker is a game of numbers. You can't avoid that. Everything is going around numbers. We have probabilities, we have distributions, combinatorics. That's a hard word. But most of all, it's a game of probabilities. And that's why you can make money in poker. If you are better in estimating probabilities and calculating them, then you can make money. Because in the long run, the one who has better probabilities to win will win, in theory. That's how casinos work. They have edge in every game. On some games, the probability is higher, on some it's smaller, but in every game that casinos normally offer, the probabilities are in their favor. Of course, you can win big in blackjack. You can win million in roulette, but in the long run, the probabilities will kick in. You can't avoid that. And in poker, we have this concept of EV, which is expected value. And it's a concept where we calculate that what is our value of that instance according to probability. So in the long run, is it profitable or not? Is it plus EV or minus EV? And the long run is always based on probabilities. But in the short run, the actual value, not expected value, but the actual value of the instance is influenced by variance. And you know that. You get it in with 80% equity. You're a huge favorite. But opponent has 1 in 5 chance to win the pot. And he wins, you lose. So, the concept of EV doesn't mean you win. It says that you're expected to win. But whether you win in reality, that's when variance comes in. But the more instances you have, the higher chance there is that the probabilities will kick in. In theory, you can run bad for your whole life. And you just have to accept that. Variance is a whole other thing. If we didn't have variance in poker, then bad players wouldn't play. You don't see anyone entering $100 chess tournament on Friday evening while drinking beer. Because they know they can't win. But in poker, you don't have to be the best player. All you need is to get lucky. That's why people play slot machines. I mean, imagine if there was a slot machine where on every spin, let's say your bet is $1, and on every spin you win 95 cents back. Every time. No matter how the reels come in, every time you win 95 cents back. People wouldn't play that. I mean, you have to be really stupid to play that slot. But the EV is the same as in normal slots where you can win millions. The EV doesn't change. The EV is return to play around 95 on average. So, if you have a chance to win big, then people will play minus EV games. And that's why you have so many recreationals in poker. Some of them think they are better than they are. Some of them know that they are not really good in poker, but they like the tension, they like their odds of sucking out and being lucky. But to make money in the long run, we need to be able to make plus EV decisions constantly. And pretty much what we want to achieve is that every decision is plus EV. Because minus EV decision means that we give up a win rate. Or expected win rate, that is. So how to know whether something is plus EV or not? And that's when the mathematics come in. We can also always estimate, and I think it's plus EV, but if we want to be sure, then we have to estimate a lot of things. And if we can estimate everything that's required to make the calculations, we can make the calculations and say that according to my estimations, this is plus EV. And now, the thing is that poker is a game of imperfect information. It means that we don't know everything. On chess, you know everything. The pieces are on the table. There's no hidden information except what your opponent thinks, but all the relative game information is visible. In poker, you don't know your opponent's whole card, so you have to estimate them, called range definition. You don't know your opponent's strategy, you have to estimate it. Sometimes the opponent doesn't know his strategy. He doesn't know on the turn what he's going to do on the river. And on the exact same situation, one day he might raise, one day he might fold, one day he might call. Who knows? He doesn't know it, but you have to estimate it. And if you estimate it, then you can calculate it, whether it's plus EV or not. And those who are good in estimation and good in understanding probabilities and doing the math, those are the ones who make money in poker. Some people say that you don't need mathematics, or I'm not good in math. I'm not going to learn mathematics. I'm a feeling player. I just know what to do. The correction would be that you think you know what to do, but there's no way you can be sure. Maybe you make a lot of money, maybe it's due to variance, or maybe you are natural talent. But for most players, they make minus EV decisions. And the thing is that, let's say, you make a turn call where the EV is minus 10 big blinds. Then sometimes you win, sometimes you lose. And if you don't even understand that you're making minus EV decision, you're just giving up money in the long run. You might be a profitable player, but if you could remove that mistake from your strategy, you can make more money. Or you can lucky and you just hit your flush draws all the time. And you think that it's a great thing to call with the flush draw, because you're lucky. But if you can calculate it, then it's easier to see if you're making mistakes. Because when you run good and you make money in poker, it's easy. You don't have to question your strategy. You just print money. But when things go south and you start losing money, then that's when you start to be critical about your strategy. Am I doing something wrong? Guys, help me out. Where I'm making mistakes. And often the first thing to see is that, do we actually know the math? Are we calling where we shouldn't? Are we using bad sizing to give our opponents chance to make their draws? And so on. And to be honest, I see mistakes with simple math, spot odds, implied odds every day. So let's get into it. We have two ways or two things where we need basic math. We are not going to go any super complicated formulas, but two simple things. First one is spot odds, risk-reward calculation. How much we invest, how much we can win. It's the same thing in stock markets, and once you learn the concept, you kind of start to apply it to your real life or your life outside poker. Okay, what are my risks? What are the possible profits? Is it worth it? It's like insurance company. We do this kind of risk management every day in our life. Okay, traffic light went to red, but I'm in a hurry. Is it worth to run over? I don't see any cars. Okay, my odds just got a little better. But in poker, it's always risk-reward calculation. If we know how much we need to invest and we know how much we can win, then we can calculate how often we need to win to be break-even. And that's the pot odds. We know how much we need to put in the pot, and we know how much we're going to win from the pot. And then we can make the calculation. Then another thing is implied odds. How much we can win in the future. Okay, we know how much is in the pot. And if we invest money to the pot, we know how much the pot would be. Sometimes our probability is not enough. But if we estimate that if I make my hand, I can get more money from my opponent. So it's the future profits then we can calculate how much I need to get that future profit to justify the call. And those are called implied odds. And in PLO, implied odds is super important concept. And even good regulars make mistakes regarding to implied odds a lot. So if you can understand and you can estimate them quickly enough, then you can play your draws way more profitably. So let's start with the pot odds. And the easiest way to calculate is our investment divided by possible winnings. And here's an example. Before that, it's just the number you're going to see, investment divided by profits, is going to give you the break-even equity needed. It will give you a number that is a percentage how often you need to win to be break-even. And if our probability is higher, it's plus EV. If our probability is lower, it's minus EV. It sounds simple. An example is here. Pot is 20. Opponent bets 15. Let's say opponent shoves 15 on the turn. And we have a flush draw. Should we call? Should we not? If we call, the pot would be 50. So we know that, okay, we're going to invest 15. And the possible winnings would be 50 on the river. So we divide our 15 with the 50. And that gives us 30%. So now the break-even point is 30% equity. If our draw or hand has over 30% equity, it would be plus EV to call. If our hand has less than 30% equity, we need to fold. And let me show you an example hand. We are on the big blind. Let's make ourselves a hero. And cutoff is our nemesis. Cutoff opens. We call and we flop the king high flush draw with some backdoor straight stuff. Flop goes check, check. An opponent is short. He has only $5 behind. Pot is $7.50. Turn is an ace. Opponent shoves $5, and we are quite sure he has an ace. So, let's say we know that we have exactly 9 outs. All the diamonds in the deck. Can we call? And I just showed you how to calculate pot odds. What do you say? Can we call or not? Of course, Poker Juice is a cheater. It shows you here the pot odds 28.57. And as we have 20, because somehow we know the opponent has the ace, it's not enough, so we can't call. But what if we put here $10 into opponent's stack, and we estimate that if we call and diamond comes, we will win that $10. He's not folding an ace on the river. And we now call. Now we have implied odds. If that $10 implied odds is not enough, how much it is? And to call here with a draw, especially when the opponent's range is very defined, you need to know how much you need implied odds, because then you can estimate how likely it is that we get that. And how much should we bet on the river? What do we know about the opponent? And this is where people make a lot of mistakes. They call here with a flush draw. They call. And then the river is a diamond. And what they do is they check. An opponent checks back. And now they win the pot. They're happy about it. But on the turn, they made a minus EV call. Of course, the opponent could have the ace high flush draw, but let's say we estimate he would bet that on the flop, so we have on the diamond outs. So this is what often happens even with good recs. They call here without the required odds, so they need implied odds. and then they check the river, opponent checks back, and they miss the implied odds. So let's go to those implied odds. Yeah, here's the same thing I already said, that if we call with less than 30%, it's minus EV. If we have over 30%, it's plus EV. So the concept of EV is here. It's either plus or minus EV. But for the implied odds, sometimes we have less what pot odds require. As in that example, we need 28, we have 20. How much we need? And now the thing is, if we can get a value after we make our hand, it's called implied odds, and we need to consider it. And on every poker book or article about implied odds, what they give you is really complicated formula. And for myself, I don't like formulas when there's numbers and different characters, and it's really weird and complicated. Most people don't like formulas. There are the math people who like them, but normal people, they get confused with formulas. So I like to keep things simple. And for implied odds, the simple way is to use a slightly different method. But here's an example. Pot is 20 on the turn, and opponent bets 15. Same as before. And we have that flush draw, which is 20%. And it's less than the 30% that is required. So the question is how much we need to win on the river. And what would be your estimation? And how do you calculate it? There is a number that is going to be enough. But what is the number? So the way I approach implied odds is that flush draw, or any hand that has 20% equity, will hit it 1 out of 5 times, because 20% is 1 out of 5 times. 40% would be 2 out of 5 times. And so on and so on. So 100 divided by 20 is 5. So you will hit the flush draw 1 out of 5 times. So the simple way to think is that to be break even, you need to win your investment 5 times back. Yes, if I call 5 times with the flush draw, then if I win one of those and win 5 times my investment back, I'm back to break even. So you need to figure out how often you're going to hit it, 1 out of how many times, and then just multiply the investment with that number. And that's the number you need to get value from the hand. And here we need to invest 15 times 5 is 75. So we need to win 75 in the end to justify the third call. And now comes the tricky part. We include that investment to the pot. So after the third call, the pot will be 50. So we need 25 more on the river. And now people think that, okay, if I bet 12.5 and opponent calls, I win 25. No, you won 12.5, so you need to win 25. So on the river, you don't calculate your own investment anymore. You need to get pure value for 25. So the question is, you have to estimate whether your opponent calls over half a pot bet on the river or not. If he does, you can call. If he doesn't, you have to fold. So then comes the confusion. When do we add our own bet or call to the calculations and when not to? And this is something that I had huge problems when I started playing poker. There was an article about pot odds and then a quiz. And I just failed the quiz over and over and over again because I didn't understand when do we calculate the own bet and when do we not. And now it seems so simple. The way I figured out is every time when I had these calculations, I tested my formula or my way to calculate. I tested it with simple example. And the simplest examples are coin flips and dice rolls. Okay, in coin flip, if I put $1, you put $1, then I invest $1 to win $2. So that's 50%. So then I calculate my own bet. I'm going to win 1 out of 2 times. I'm going to break even. Or if I'm not sure, then let's say on coin flip, there's 2 outcomes. So then I just wrote on paper that, okay, on heads, or if I make 2 coin flips, on one I lose, one I win, total amount of money I have in the end is this. Or dice rolls. And imaginary, you can have 3-sided die, 5-sided die. So you can test the way you calculate. And if it ends up being the sum of 0, then your way is good. If you're not sure. And then you will see that, okay, there aren't many ways to calculate. The only difference is in pot odds, direct pot odds, you calculate your investment. Implied odds, you don't calculate your future investments. So those are the 2 basic mathematical situations. Of course, we have these more complicated, like when we define a range for opponent, how often he has a flush draw compared to made hands, and if we bluff and blah, blah, blah. I mean, bluffing is just pot odds. Let's say there's $10 in the pot, and then we bet $10. How often the bluff needs to work? Well, we're risking $10 to win the pot of $20 if the opponent folds. So 10 divided by 20 is going to be 50. So half of the time. So if we make a pot size bet, then, or actually 0.5, but that's 50. So we need to be successful in the bluff 50% of times. All right, if the pot is $10 and we bluff with $5, we're risking 5 to win 15. 0.33, which is 33%. We have, or the bluff has to work at least 33% of times. So when you know how often the bluff needs to work, then you think about your opponent range and estimate what part of his range he's going to fold, and then you will know whether the bluff is profitable or not. So bluffing is not some mythical thing that you know just so read your opponent when he's going to fold. It's just pure mathematics. It's about range definition and then calculating, does he fold often enough? So it's kind of pot odds in slightly different way. But we often use the pot odds when we are calling. We also have to use it when we are betting. Like if you have a top set and you're quite sure that your opponent has a flush draw, then bet big. If you bet like 1/3 on the turn, you give your opponent a chance to make a plus EV call. And the thing is, every time when your opponent makes a plus EV call, then his call doesn't generate profits for you. Of course, you have high equity and it's profitable for you too because there's money in the pot. But to make money, your opponent has to do minus EV decisions. Someone has to make minus EV decisions because it can't be profitable for everyone unless there's miracle money appearing to the table. So let's say you know your opponent has a set and you make a flush and then you bet half a pot on the turn. You just gave your opponent almost the odds to call. Don't. You have to use bigger sizings. So when we are playing with the draw in hand, how do we estimate our equity? That's often the hard part. How do I know how much I have if I have a combo draw? Well, in PLO, estimating equity is pretty important, and the idea is that if you know your outs, you know your equity. And in PLO, you can estimate your chance to hit your outs on the next street, whether it's turn or river. It doesn't matter. It's a 2+2 formula. That's the only formula I use in poker mathematics. It's 2+2. Easy to remember. It's outs times 2 plus 2. So let's say that flush draw, which has 9 outs. Then it's 9 outs times 2, which gives us 18, plus 2 is 20. So you're going to hit one of those 9 outs 20% of times. And if you want to be precise, if you have over 10 outs, 11 or more, you can use times 2 plus 3. But even if you use 2 plus 2, it's not a big problem, because often when you have over 10 outs, you have equity to call anyway. But this is the way to estimate equity, and then you can make the pot odds, implied odds calculations, everything. If you are on the flop and someone shoves all in, then what you can use is outs times 4, how often you're going to hit one of those outs on the turn or on the river. But a lot of people do a mistake here. They put the flop, let's say on the flop, the opponent bets and you have a flush draw. And then they put the hands to equity calculator, which gives the flush draw 35% equity. And in PLO, the maximum you need is 33 because it's a pot limit. So they think that, okay, even if opponent pots, I have 35%, I can call. Wrong. The equity that the calculator gives you is if the hand goes to showdown. So it's your equity if you see the turn and river. But in reality, you won't see the river with that same price. If opponent shoves the flop, then you will. But if he bets and you call and you miss the flush draw, then he will bet more on the turn. So what you have to do is play one street at a time. So on the flop, what you need to think is about implied odds. Okay, he bets pot. I'm going to hit 1 or 5 times. If I make it, I need to get 2/3 of the pot for value. If you think you can get it, then you can call. Most of the times you won't get it, so you have to fold. So understand, in equity calculator, the number is if the hand goes to showdown. But in PLO, we have to play one street at a time. So that's why you have to use the 2+2 with implied odds if required. All right? So here's the basic poker math, and it's not that complicated. You don't need to be a mathematical genius if you understand these two things, pot odds and implied pot odds, that will get you really far in poker. Then the more complicated ones are the range definition and estimating how often opponent has certain parts of his range and so on. Or how many, well, in PLO we don't really think how many combinations opponent has, because there are so many, thousands and tens of thousands of hand combinations. So we just define the range. It's slightly different than in Hold'em. But I hope you enjoyed these ones. If these were just simple and too easy for you, it's your bread and butter, congratulations, you are doing well in poker. But if you struggle with pot odds, or if you struggle with implied odds, then practice those so much that they become automatic, because on the poker tables you have a time limit. If it takes you 30 seconds to calculate implied odds, you can't use that because often you have less time on the table. So practice them as much as you can so they become really automatic. You can make good estimations really fast, because that generates more profits on the tables. All right. Hope you enjoyed. I will see you on the next video. Be safe in the galaxy.